everybody. Oh, thank you. Thanks, everybody. I'm so happy to be here. I'm so glad so many of you could make the trip to Toronto, and so happy with how this conference has been going so far. So my name is Josh Stark. I work for a company called L4. L4 is building Web3. If you've heard of us, you've probably heard of either the Stable Fund, our partnership with MakerDAO, a fund that gives out grants and makes equity investments in projects that use the DAI stablecoin. Or you've heard of Counterfactual, our project to build the best open source generalized state channels implementation to make it easy for developers to use state channels in their applications today and make this network scale. But today I'm going to be kind of giving a talk loosely based on an article I published last year called Making Sense of Cryptoeconomics. If you're interested in this idea and reading more, I encourage you to check it out. It's a little outdated now compared to this talk, but I think it still holds up pretty well. So this talk is about cryptoeconomics. We've heard that term a lot in the last 45 minutes. It was in Vlad's talk, it was in both the sharding talks. This morning, Carl talked about an introduction to cryptoeconomics. Closer? Okay. Carl talked about an introduction to cryptoeconomics, and in Jeff's talk, he talked about mechanism design and how everything is a mechanism. So we're going to take this kind of from the details to like way up to like a conceptual explanation to kind of make this idea clear. We're going to talk about what cryptoeconomics is not, first of all. We're going to talk about what it is and try and offer a definition that gets us towards that answer. And then briefly, why it matters, why it's an important idea to understand. So first of all, what is cryptoeconomics not? If you take nothing else away from the next 10, 12 minutes, take this away. Cryptoeconomics is not trend analysis. It is not looking at charts and trying to decide when to buy a token. Cryptoeconomics is not trend analysis. It is not trying to figure out when to buy Ether, and cryptoeconomics is not trend analysis. So you can stop paying attention now for some of you, but everyone else, please keep listening. Secondly, it is not just the economics of cryptocurrencies. If someone is doing something that could loosely be termed economics, maybe thinking about monetary policy or how this will affect existing financial infrastructure or just microeconomic analysis of different markets, that can still be fairly called economics. It's a new object of study for economics, and it will teach us new things about markets and new things about how people react to incentives. So maybe it's the economics of crypto assets, of cryptocurrencies, of tokens, but I don't think it needs a new name. And when people first started using the term cryptoeconomics, they meant something much more specific, and that's what I'm going to help try and define for you today. So what is cryptoeconomics? I think I have a definition that gets us pretty close to an answer. I'm eager for feedback on it if you have it after the talk, but let's start with that to kind of get towards the idea. So cryptoeconomics is the practical science of using economic mechanisms to build distributed systems where important properties of that system are guaranteed by financial incentives and where the economic mechanisms are guaranteed by cryptography. So this has basically three parts to it. And the way we're going to look at this is by looking at each of these parts in turn and explaining why it's important in this definition. So first of all, cryptoeconomics is about building things. It is a practical science. It is meant to be applied. There's obviously theoretical components to it, like a lot of what Vlad does, but these theoretical investigations are driving us towards building systems that are useful for people. Bitcoin, proof of work, Ethereum, proof of stake, sharding, state channels, plasma, these are all applications of different kinds of cryptoeconomics to build stuff that is useful for people. So that's the first thing. The second thing, we are using economic mechanisms to build distributed systems. So we've heard a couple times this idea of mechanism design or mechanism design theory, and cryptoeconomics is most similar to that. Mechanism design is a subfield of economics very related to game theory. And an easy way to explain it is that it is reverse game theory. With game theory, we might look at some sort of strategic interaction, a game, a negotiation, even evolutionary biology, and we might try and figure out like what are the best strategies for the participants, and if everybody acts in a rational way, what is the likely outcome of that? With mechanism design, we do that backwards. We start with an outcome that we want to create, and then we figure out, well, assuming that people act in a self-interested manner, what game can we design, what mechanisms can we design that, if we create it, will produce this outcome? Without getting ahead of myself, Bitcoin is a product of mechanism design. Satoshi had certain goals for what Bitcoin would do and went about building a game, a set of mechanisms that would produce this useful thing called Bitcoin if people were interested in economic rewards. So the third part kind of has like two pieces to it. So we're going to subdivide this even further and say that, cryptoeconomics involves where important properties of the system are guaranteed by financial incentives, and also where the economic mechanisms we use are guaranteed by cryptography. So let's look at each of these in turn. So firstly, financial incentives play a critical role. None of this would work if people didn't care about getting money. If all of the people in the world stopped caring about winning the Bitcoin block reward tomorrow, there would be no more blocks. We are assuming that people continue to be interested in financial rewards. They will continue to buy computers and mine things to win that reward. It is a non-negotiable part of all of this stuff. It is absolutely necessary. And what this also means is that the kind of guarantee that we're giving, and here guarantee doesn't mean 100% this never fails. It means that we have a guarantee of some strength. And that can often be measured in economic terms. So one of the guarantee that a blockchain like Bitcoin or Ethereum can offer is, well, we are safe against a certain category of attacks, like a 51% attack, unless some actor is willing to spend some astronomical sum of money we call X, right? That's a cryptoeconomic guarantee that the system is secure up to some certain point, and we can measure that. We can tell you about it. Next, the economic mechanisms that we use are guaranteed by cryptography. This is all over the place. To use the simplest example, in Bitcoin, many parts of the rules of the game that makes up Bitcoin require cryptography, right? So we use hashing algorithms to prove work. We use hashing algorithms to select random winners because we don't want anyone to know ahead of time who will produce the next block, because that would make the system insecure. We use the one-way property of hash functions to make it difficult to edit to the blockchain without someone noticing. And of course, we use public and private key cryptography to guarantee that people can have exclusive possession of the digital asset that they're being rewarded with that incentivizes them in the first place to participate in the system. None of this would work if we didn't have these properties of cryptography. So this brings us to kind of like why this is all special, and why we had distributed systems in the definition earlier, which is what's great about both financial incentives and basic cryptographic primitives is that we can assume that they work the same everywhere. I don't have to know anything about you to know that if you run SHA-256 on your computer, it'll work the same way it does on my computer. I don't really have to know much about you to know that you probably care about having more money than you do currently, and I can exploit that fact to convince you to do things. This is what makes it possible to build these distributed systems that nonetheless produce coordinated, complex behavior that produces useful outputs like a global payment system or a global platform for decentralized applications. This is what makes it socially scalable. So some examples of things that are parts of cryptoeconomics: consensus protocols, proof of work, Casper, etc. We are trying to design a set of mechanisms that allows some distributed system to agree on state with some regularity, and also to do that most efficiently. Scaling solutions, layer 2 scaling solutions like state channels, Plasma, Truebit are also cryptoeconomics. They're different. We're using a different set of tools sometimes, and we're using smart contract code, and we're probably concerned with a smaller set of actors, at least in the case of some state channel versions. But nonetheless, we are trying to produce this outcome using mechanism design, using this common toolkit. And also some applications or protocols are cryptoeconomics too, where you're trying to coordinate some mass behavior that is beneficial, like decentralized prediction markets, like auction systems, and like decentralized markets for computation and storage. Those can also be perhaps achieved using cryptoeconomic design, using this common toolkit. So why does this matter? It matters especially because people tend to think that blockchains are magic. We see people that just think that, Bitcoin is backed only by math, or that this thing is completely trustless. We don't need to trust anyone anymore. These are, of course, wrong. You are trusting in 1,000 people's incentives continuing to be predictable into the future. We are making assumptions. You are trusting cryptography in some sense. Those might be very safe things to trust. They might be very valid assumptions. But nonetheless, you're trusting something. It's not magic. It's just interdisciplinary. We see people that come from a computer science background that don't appreciate the economic role in these things, and that kind of allows them to abstract away the necessary role of incentives in these systems. And likewise, we see people that come from an economic or a financial background and don't appreciate the powerful tools that cryptography gives us. So the last thing I'll say is just that this is here to stay, and it's a very useful organizing concept. We went from a world where it was Bitcoin and that was it, to thinking, well, maybe that there's other applications of this underlying thing called the blockchain. And now I think we're getting to a point where we realize that there's this kind of collected body of knowledge that allowed us to build Bitcoin and allowed us to use blockchains in different ways, called cryptoeconomics, that can build new things. Any individual blockchain can be destroyed. It's possible that Bitcoin and Ethereum don't exist in the future. It's possible that the blockchain design is not the end-all design of creating distributed state systems. And if we build something better, and I think that the people in this room are going to be the ones that do that, we're going to build the better thing using this body of knowledge, using cryptoeconomics. So, go forth, understand, document, and build, and understand this concept because it's very, very critical. Thank you very much.